In example 4 here, we say let V be the space given by this set. So this is C1, X1. So it's a linear combination of these variables, X, Y, and Z, such that C1, C2, and C3 are real. Okay? Now this is going to be under natural addition and scalar multiplication operations. Then V is isomorphic to P2, which is a set of quadratic polynomials. Now, how are we going to show this? Well, we just have to show that the conditions are satisfied. So we have to pick, well, a mapping. Right now, there are more than one mapping we could choose. So, for example, we could have where we have just the natural mapping, which would be C1 plus C2x plus 3C3x, oops, not cubed, squared. Or we could have F2, where we have C2 plus C3x plus C1 x squared. Or we could have everything with subtraction. So we could have minus 3, 2 minus C1. Let's do C1. C1, C2x minus C3x squared. And a fourth one we could come up with is call it F4. Let's say C1 plus C1 plus C2 times x plus C1 plus C3 times x squared, right? So the idea is there's more than one mapping that we could come up with that would be isomorphic, okay? The natural one would be the first one, okay? But we're actually going to use the second one, okay? Just to show that it works. So we'll do this one, F2. So now that we have this mapping, we want to show that it's isomorphic. So V is isomorphic to P2. We have to set, show the conditions, 1 and 2. So let's start with 1. So now condition 1 is we want to show that the mapping is both 1 to 1 and onto. So now to show that it's 1 to 1, we start with if f of, let's do a1 plus a2x plus a3x squared is equal to f of b1 plus b2x plus b3x squared. That it will inevitably give us that a1 is equal to b1, a2 is equal to b2, and a3 is equal to b3, right? So let's do let's see where it takes us, right? So obviously this is going to give us what? This is going to give us A2, oops, not AC. This will give us A sub 2 plus A sub 3 x plus A sub 1 x squared, right? Which is equal to f of, oops, not f. Oh, hold on a second. Oh, I'm doing this wrong. I'm not paying attention here. This is a1x plus a2y plus a3z. And this will be b1x plus b2y plus b3z. That's what I wanted to start with. Sorry about that. And then the mapping will bring us to this. So a2, a3, and a1, and this will be b2 plus b3x plus b1 x squared. Oh, okay, now that's what we wanted to do. Okay, now, well, what do we know about polynomials? We know that polynomials are equal only if what? The corresponding coefficients are equal. So this means that this implies that a1 is equal to b1, a2 is equal to b2, and a3 is equal to b3. And we're done. So now we showed that it's 1-to-1. Now let's show onto, right? So now let's take any member of the codomain, right? So if we take any member of the codomain, which is going to be, how do we want to write that? I'll just say C1. Well, let's just do A plus BX plus CX squared, right? And so we want to show that that is the image of some value in the domains, right? So we're going to go and rewrite this. Okay, and again, it's going to be pretty straightforward. So for every member of P2, there is an image of a member in the domain. So in other words, oh, how do I want to do this? Right, in other words, f of ax plus by plus cz equals that. And so it's obvious to see that for every value or every member of P2, there's a corresponding member in V, which would be, in this case, AX plus BY plus CZ, where A, B, and C are real numbers. Okay, so now we satisfied the first condition. So now we're going to look at the second condition, see if it's satisfied by looking at whether the operations preserve structure. And so now what I'm going to do is start with addition, right? So we're going to do f of a1 plus a2x plus a3x squared plus b1 plus b2x plus b3x squared. Okay, now we're going to show that addition is preserves the structure, right? Or that the structure is preserved in addition. So now what I'm going to do is I'm going to do the same thing. I'm going to simplify this by dropping the parentheses and adding like terms and then regrouping. So that's going to give me this. Okay. Now let's apply the correspondence. So that means I'm going to get A2 plus, oh gosh, I keep messing this up. Keep putting the image in here. Okay, let's fix this. I keep wanting to write the polynomial. Sorry about that. Start over here. So this is going to be A1 x plus A2 y plus A3z. And this is going to be B1 x plus B2 y plus B3 z. Okay, now I'm going to do the same thing that I was doing just now the correct way. So now it's going to be, again, A1 plus B1 times x plus A2 plus B2 times y plus A3 plus B3 times z. Okay, so there we go. I'm sorry about that. So now, at this point, now we're going to apply the correspondence. Okay, so now it maps to this, so that means we're going to end up with what? A2 plus B2 plus A3 plus B3 times x plus A1 plus B1 times x squared based on the mapping we chose, the correspondence we chose. So now, where do we go from here? Now we're going to go backwards because this can be rewritten as what? This can be rewritten as A2 plus A3x plus A1x squared, right? Plus B2 plus B3x plus b1 x squared. And then of course, this is equal to f of a1 times x plus a2 times y plus a3 times z plus f of b1 times x plus b2 times y plus b3 times z. And we're done with addition. So we just showed that it preserves the structure. All right, awesome. Let's do the same thing, and hopefully I won't make a mistake, with scalar multiplication. So again, I'm going to start with, now the correct one. So let's start with f of r times what? A1 times x plus A2 times y plus A3 times z. And again, I'm just going to distribute the r, so that's going to be, and again, this is just for some scalar r in the reals, right? So this is going to be f of r times a1x plus r times a2y plus r times a3z. And now I'm going to apply the correspondence, the mapping. So here we go. This is going to be equal to what? It's going to be r times a2 plus r times a3x plus r times a1 x squared. And now I'm just going to pull out the r, which is the same as r times the quantity a2 plus a3x plus a1 x squared, which again is equal to r times f of a1x plus a2y plus a3z. And there we see that scalar multiplication is also preserved, and therefore F2 is an isomorphism, which means we can write, what was it? V is isomorphic to P2. And that's it.